Hello and welcome to session 327 in the AISafety.com reading group. Tonight we'll discuss the article Book Review, If Anyone Builds It, Everyone Dies by Nina Panickssery. 9 days ago, Eliezer Yudkowsky's book If Anyone Builds It, Everyone Dies was released. So the big question here is he right? Does everyone in fact die? So this book was reviewed by a fair number of people who expressed their opinions and responses, and some reviewers were totally dismissive, and some reviewers accepted every word. But more interestingly, some people actually engaged with the book and the arguments. Of these reviews, most were outside view, but there were a few that actually wrote detailed responses to the object-level claims. And this presentation is basically about those object-level counter-arguments that were deployed in response to the book. One person who reviewed the book but did not really engage critically at any particular detail level was, somewhat disappointingly, Scott Alexander. Scott mostly agrees with the arguments, but he didn't go into details about precisely which parts were the reason why he didn't accept the total conclusion. I think this is a shame, and I think it's a huge missed opportunity to have someone who is capable of engaging with the arguments and not doing that. And in particular, some of the areas were within the field where Scott has some kind of expertise, and I think those would really have been valuable to see his comment on. So instead, Scott Alexander decided to psychoanalyze his opponents and asking for forgiveness in advance. And I think this is a poor move. It always derails the conversation. So this literally never works, ever. So one person who got baited into answering this was Nina Panickssery, who wrote a review of the review. And I won't engage with that, because I only want to look at the object-level arguments. So I'm just going to extend my apologies on Scott's behalf, and let's look at the object-level arguments. Now, of course, before we go into the arguments, I just want to take a brief moment to thank Nina Panickssery for engaging critically with these arguments. That is very helpful. My screen fell off. Oh, so that was, sorry, that was a bit, yeah, for engaging critically with our arguments. So to situate ourselves, let's look at how both Eliezer and Nina choose to structure their arguments. In the book, If Anyone Builds It, Everyone Dies, Eliezer presents a pretty clearly defined 6-clause object-level argument, and this is written into like 6 sections of the book, part 1. This list of arguments won't really be a surprise to people who have followed his writing, because it's the same in many other things he has written and that Bostrom has written and many others. It's a pretty standard argument. But I've found 15 reviews that deal with the object level in a critical way, and it turns out that none of these 15 reviews make any kind of reference to the structure that Eliezer has. And Nina is, in fact, the one who comes closest. But she presents a summary of Eliezer's argument, and her summary doesn't really map neatly to the original. So here is the list of her 4 restated object-level claims, which we'll go through in this presentation. And there is some kind of vague mapping from the discussion about training goals to the last 2 claims, maybe, if you kind of squint. It's not a big problem, because in general, I think it is acceptable to restate the claims that you're responding to. I do this in this presentation as well. I move things around somewhat. But I do think that Nina, and especially all the other skeptics, would benefit from a bit more rigor in how they engage with the structure that Eliezer presents. So the first claim, Nina's first claim, is that superintelligence will eventually exist. And that's, of course, a claim that exists in the book, but it isn't very central, because the book is called If Anyone Builds It, Then Everyone Dies. So it's a conditional. So it's not really necessary for the book to establish that superintelligence will eventually exist. But Nina takes this as a foundational claim, and she rejects it because it's just too hard to reason about. And I don't actually think it's that hard to reason about, because you can certainly come up with a lot of reasonable arguments, both for and against, and under what circumstances. Nina's objection is that, yeah, but if it takes 1,000 years, then the world is probably very different, because what will the world look like in 1,000 years? I don't know, but I think looking 1,000 years ahead is way too long, because we may in fact be facing superhuman intelligences very soon. And Eliezer explicitly disagrees with me, because I have pretty short timelines, and he, in his book, is much less certain about how long time until there is a superintelligence. But in general, is it possible to predict technology? How hard is it, and when can you predict a technology? Eliezer in the book talks about easy and hard calls, with inspiration from nature in what is possible, and inspiration from the limits imposed by physics for what is not possible. Nina objects to this because, yeah, many things are theoretically possible, but they don't actually end up happening. I think that is of course possible, but that's not really the thing we are talking about here, because Nina is personally working for a company that's trying to build a superintelligence, and that's probably really important information about the feasibility of building a superintelligence. Rob Bensinger from MIRI clarifies on Twitter or X that we are talking about not just anything, but things that were correctly thought feasible for 100 years. And I think Rob's answer is too narrow compared to Eliezer, because 100 years is a lot longer than we've had any idea about AI or superintelligence. Like, there's a sense that we've only really tried to build AGI over the past 40, 50 years or so. And also, correctly thought feasible is a bar that is, in fact, a lot higher than the one Eliezer makes in the book. But to her credit, Nina, to some extent, accepts this answer and clarification, and she does update, which is in fact laudable. As for me, like, I can in fact I can mention a lot of technologies that have been predicted but haven't been realized, like cities under the sea. And for me, the core reasons why we don't get them is related to incentives, because no one wants or needs to live under the sea. That's why we don't have cities under the sea. But AI is centrally different in this regard, because improving AI has massive short-term incentives. Another claim that Nina extracts from the book is the claim that superintelligence will emerge soon. And here we are talking about timelines, not takeoff speeds. We'll call that later. So Nina claims that Eliezer is arguing that superintelligence will probably come soon. And I think, like, Eliezer stresses again and again throughout the book that he is in fact not predicting superintelligence soon. He does not know. So I think this seems like a clear error on Nina's part. And Nina counters this perceived claim by really confidently predicting that future AI will require three things: a lot of compute, data, and cognitive effort. The a lot emphasis is in her text. And like, it's not really clear to me what previous improvements needed all of the three. But that of course depends on your granularity. Like, if you say something like the deep learning revolution, yeah, maybe that will do, but it's composed of many smaller things. So one thing throughout Nina's text is that she accuses Eliezer of extreme overconfidence. And I think if we look at this specific point, I think the overconfidence is on Nina's part, not Eliezer's. Okay, but let's leave aside the thing about confidence. Like, is superintelligence in fact coming soon? And does Eliezer believe that superintelligence will come soon? Like, he has a scenario in the book in part 2. So when does the superintelligence happen? And unfortunately, he is very, very explicit in not giving any kind of indication on a date in part 2 of the book. I think I can still speculate. This speculation is on me, but I'm seeing 3 moderate algorithmic improvements compared to what we have now, and at the rate at which we're getting algorithmic improvements, I would say probably 2027, but that's my overall take. So before the next claim, I want to talk a bit about takeoff speeds. Like a takeoff is at the speed of a takeoff is the time between the time when AI is as smart as a baseline human and it being a superintelligence. In particular, a superintelligence powerful enough to take over. And the classic definition of takeoff speed is given by Nick Bostrom in his 2014 book Superintelligence, which is pretty widely cited, and I think would be the general text for this. But in this book, Eliezer Yudkowsky, in the book If Anyone Builds It, Everyone Dies, he does not at any point use the word takeoff. Later, Nina will argue that takeoff speed is really central to Eliezer's argument. And like it can't be that central if he doesn't mention the word, right? There is some kind of misunderstanding here that needs to be cleared up. Bostrom has a graph, but Eliezer does not have graphs and this kind of formal language in his book in general. Very much in contrast to Nick Bostrom, who proudly placed a damn hard read that a reviewer wrote, and he put that quote on the cover and wore it as a badge of honor. Okay, but again, let's return to what will actually happen and what does Eliezer think will happen. So he has a scenario in part 2 of the book. So what takeoff speed is there in his scenario? And unfortunately, again, Eliezer explicitly doesn't say. He doesn't give any hint on how long time it in fact took to develop the AI that is in the scenario capable of taking over. I can again speculate for my own part. I think the fictional company Galvanic built the fictional AI Sable in something like half a year, but that's mostly based on vibes and the general pattern of releases of new models and things like that. However, in Nina's article, it seems like she's operating with a quite distinct definition of takeoff speed, though she does not in fact give the definition that she's using. Because she refers to the deployment of this AI Sable as an extreme fast takeoff scenario. And she's only talking about the deployment. She's not considering the training time at all. And I'm not really sure that defining takeoff speed through deployments cuts reality at the joints. Because like there was a time, if you go back to last year, the 29th of August, there was a specific time where no AI in the world could do structured output like JSON. This was a thing AIs could not do, and then 1 minute later they could. And that's of course because GPT-4 was released, right? So there's a sense that compared to structured output, we had extremely fast improvement. Because like maybe the benchmarks in general went up 10% over 1 minute, but like that's not really meaningful to talk about the speed of deployment, because deployments are like, I think in full generality you can say that for any tasks that is either pass or fail, then there will always be one instantaneous deployment which turns failure into success, right? So you will always, by this definition, you will always have precisely one deployment that succeeds. So any kind of improvement will always be instantaneous. I think it's a bad definition. Okay, again, we can interrogate Eliezer's world model through his scenario. So is the AI in his scenario like a large discontinuous improvement, or is this a fast Nina takeoff in that sense? And somewhat frustratingly perhaps, Eliezer doesn't say, right? The only thing he unambiguously say in his scenario is that the developer of this new AI says that the new AI is, quote, amazing. And I know Eliezer a bit, and I'm really confident in saying that that is obviously like deliberate ironic hyperbole, like a parody of Sam Altman or something like that. But in this scenario, like it has to be 1 iota smarter than the previous models because the previous models couldn't take over. So how large of an improvement is it? I guess maybe probably a normal sized improvement, kind of like the ones that we see right now with GPT-4, GPT-5, something like that. But the text is actually on a narrow reading somewhat unclear, because how much better is this AI compared to the AIs that we have now and the previous models? It might be that the architectural improvements are new to this AI. It is possible to read the text like that. And I want, in fact, to dive deeper into the topic of architectural improvement, because I think this is actually really important to have a good model of this. This isn't something that Nina writes much about explicitly, but I think she has a model here that differs from mine, and I'd like to learn more from her model. So assume, for the sake of argument, that in this scenario, the only reason why the takeover works is because of the parallelism, this improvement so that the new AI is dramatically more capable. And we can also assume that Nina basically grants that effective parallelism could be a major discontinuous improvement. And we further assume that Nina thinks that this kind of quantum leap is implausible or unlikely. Again, I don't really know if this is a crux for her, but this could be a part of the reason why Nina keeps returning to this superintelligence appearing suddenly. So in Eliezer's scenario, the AI has something that is roughly like a reasoning model, but it's just improving by being run more in parallel instead of being run for a longer time serially. Of course, using Nina's definition of takeoff, then reasoning models also had a fast takeoff, in the sense that there was one day when there were no reasoning models, and then the next day there were reasoning models. So they appeared like from one day to the other-ish. So my central confusion here is about Nina's model of architectural improvements, which seem to have two conflicting properties. The first is that the kind of architectural improvements like reasoning models, these are things that are extremely realistic to happen overnight, right? Because they do happen. And the other thing is that architectural improvements like parallelism is very unrealistic. I think Nina thinks that something like that happening is very unrealistic. And that's a strange model. I don't understand her model, and I'd like to know more. There is something that might be kind of an answer to this, in that Nina objects that the AI self-improvement doesn't really justify this kind of improvement, like architectural improvement. And that may be true, but in Eliezer's scenario, there is in fact no mention about whether this parallelism is invented with AI help, or if it's like only humans that have been involved in the development of Sable. However, overall, I think Nina is right. Right to be finding that this kind of stepwise improvement is underdetermined. It could happen very, very, very gradually. There have been architectural improvements, but we could enter a regime where all the improvements are very, very continuous. That's the thing that could happen. And the argument that Eliezer brings doesn't really hinge on these discontinuities. So the same scenario would have worked where Eliezer says that, like explicitly says that this new AI that takes over is only a tiny bit smarter than the previous. I think that would have been a better scenario. But of course I recognize that Eliezer, he shouldn't write my mainline scenario. That's not why he's writing that book. Okay, let's get back to Nina's review and response. Will superintelligence relentlessly pursue its own goal? And this is the claim that Nina extracts, but I feel this claim doesn't in fact cut reality at the joints. I would prefer splitting relentless from own goals, because those are two pretty different claims. And Eliezer has a pretty long argument for how an AI comes to go hard, as he calls it. But Nina objects to this, that this doesn't establish why it would reach a perfectly unified goal. And for the first part, it does in fact establish like this relentlessness of going hard. I don't know if Nina actually objects to this, but I think that is in fact established. So the other argument is will there be a unified goal? And I think there will in fact be one. I base that on the von Neumann-Morgenstern utility theorem, but Eliezer does not do that. He does not write about that in the book. And it also isn't really required for the argument. So I could not find where Nina got this idea of a perfectly unified goal. I don't think it's in the book. Nina also objects that Eliezer doesn't, with his argument, establish that, quote, machine learning will find the most general solution. And I unfortunately was not able to get Nina's point here. She also argues that Eliezer doesn't establish that you, I don't know who that is, don't know what the most general solution looks like. And I'm pretty confused about what's going on here, and I hope in the discussion afterwards some of you will have something so we can figure this out. The next claim is that these relentlessly pursued goals will result in our destruction. And Nina starts her argument out with like a big part, 5 sections about evolution. But I didn't see those ending with an argument, so perhaps I read that wrong. But the key central question Nina ends up with is like, what are the emergent goals and how coherent and persistent are they in the models that we train? She seems to accept that the book establishes correctly that we can't precisely specify goals. But in her reading, Eliezer uses a much stronger conclusion that the AI will pursue a completely alien goal. And this argumentative leap is made in a completely unrigorous fashion. And I mean, depending on your standards for rigor, Nina is correct here. There is less rigor here than you would find in Bostrom or in other texts, right? There is, however, a 23-page argument for this. And it is not perfectly rigorous. It does use analogies and fables, but it is there and can be examined. And Nina, of course, has read this. That's very clear. And her examination doesn't find any explicit flaws and errors in these 23 pages, though she does find counter-arguments. So, I mean, Nina ultimately is writing a blog post article that is just as unrigorous. And there's an obvious reason why she's doing this, because we don't know enough about the subject to actually make rigorous claims about AI safety. That's why you can't expect rigorous claims in any direction, which is a problem in itself. But Nina does have some concrete arguments for why we should expect human-compatible goals. And the first argument for why we should expect this is that we are the ones training the AIs. And this is in fact an argument that is discussed in the book in the previous chapter at substantial length. And I have a somewhat glib answer, is that we're lacking a causal link from us training the AI to acceptable goals. Like, why does that happen? And Nina's second counterargument is that we humans have produced the training data. And again, like, this needs to somehow causally relate to like the zeros and ones and the floating points within the giant matrices. Like, how do we go from A to B? It doesn't necessarily have to be causally, of course. It could be, I don't know, a causally contractualism or something like that. But we need some kind of story, right? Nina feels that this significantly reduces the risk of alien goals, and she cites Eliezer saying that, sure, the risk is astronomically lower, but it started out very, very astronomically bad, so it doesn't really get that much. It can still be astronomically bad. And there is, in fact, some confusion here about whether this argument is too unrigorous to be critiqued. The last argument for human-compatible goals is that we are selecting the training data. And for the base model training, like the pre-training, we basically throw everything at the AI, like everything that's ever written on the internet. So we are only selecting in a very, very loose sense there. But there are things that happen after pre-training. And for those, we do in fact steer the process. Let's look more into this. So we have an AI that's pre-trained and then trained with more things, like roughly as we do now. Would that have goals or inhibitions that would prevent it from taking over? So I'm using the word fine-tuned here. Like that's a shorthand for basically everything after pre-training. So that could be reinforcement learning from human feedback, the constitutional AI that Anthropic is using, or prompting and other techniques. So let's see in Elias's scenario in part 2. There's an AI that is trained and deployed in an environment that contains honeypots, various and this kind of tripwires. And Elias calls that clever tricks and guardrails. And Nina really strongly objects to this framing. She might be thinking about the learned behavior of avoiding them, but I think, to my mind, these kind of control structures are really clever tricks and guardrails. I think honeypots are basically that. I think it's a perfectly appropriate term. Now, again, returning to the scenario, the AI has been trained in an environment with these honeypots, so it has learned some kind of submissive behavior to avoid triggering the honeypots. And Nina objects to Elias calls this inhibitions, but Nina objects to the term inhibitions for this learned behavior because, as we'll see in a moment, she doesn't really consider it behavior. But I think the term inhibition is just a straightforward dictionary word that accurately describes the behavior. But Nina's central claim here is that the inhibitions that the AI learned are in fact something that we should think of as goals for the AI. So it has both goals to complete its task, but also the goals to avoid triggering the tripwires. I think this is important, and I think I'm really listening to Nina's arguments because there is a sense in which she's right, but there's also very important differences. Like the AI is in general like maximizing things, like maximizing how good code it can be and how happy it can make people and things like that. But not triggering a tripwire is a satisfying goal, so it doesn't really maximize that. It's also conceptually much closer to a constraint than an objective, and that might influence how it's learned. So the training is different, or at least hopefully different, because you really don't want to train the behavior away directly. Like that's the obvious stupid way to do safety, is to have a model and then just train it on not doing the visible bad thing. That's like it's common accepted wisdom that ends badly. So you have to do something different with the training, and that might mean that it learns this in a different way. And of course, there's finally the thing where developers are giving much higher priority to actually solving the task. That's where they're pushing the boundaries. They're not pushing the boundaries on precisely making sure that it stays submissive. Like if it just decides it will not try to do these things because it's too terrified of hitting a tripwire, then they're going to adjust the AI because they wanted to solve the problem. The developers will just try again. Okay, but does this happen in practice? Like, is there such a separation? Well, Elias claims that we do have at least a bit of empirical evidence about this question. So this is a topic that I will call anti-corrigibility. Let's look at that. So is there any evidence that AIs may have a desire to subvert the inhibitions as if these inhibitions are constraints and not goals? Yep, says Eliezer. We've seen this in the chain of thoughts in our experiments at Anthropic. And Nina objects to this interpretation of the experience because this is anti-corrigibility towards human-specified goals, not towards emergent goals. And yeah, it's true, but that does not change the fact that we are in fact seeing anti-corrigibility in the experiments. We are seeing this kind of separation. Nina also counters.
I mean, is there any universe in which not seeing anti-corrigibility would make you think that AIs would be safer than the opposite?
Interesting. I think there is there is, of course, the thing that if the AI is sufficiently smart, it will not show bad things in the chain of thoughts, and so we should expect less and less of that as the AI gets smarter. So I think people did in fact predict a period where the AI would try to think of this kind of thing, but we'd be able to catch it red-handed.
No, what I'm trying to say is that if we consistently see, if we never observe anti-corrigible behavior, then like AI, I think that would make AIs more dangerous because, you know, that allows the goals, the goals of the AI to float off in random directions, and if you like the small subset of human preferences, that's actually really, really bad compared to an AI that can protect its own preferences to a degree.
Yeah, so I am somewhat struggling. I don't see the fact that we see anti-corrigible thoughts as very important evidence. I think it's like mostly a coincidence that it turns out that we are able to cheat the AI in some way to reveal its chain of thoughts at this level. So if we had never seen this, I would not in fact have been feeling a lot safer, because I would think that probably the reason
I'm saying that if we didn't see this, things would be a lot more dangerous. Because I mean, because why do you think that anti-corrigible behavior makes AIs more dangerous? That's my question.
So we are explicitly talking about anti-corrigible thoughts, not behaviors. And I think that's a very big and important distinction here. So we haven't in fact seen Claude like try to take over for real. We have seen Claude try to like hide its thoughts and do different kinds of deception in more or less contrived circumstances.
But just in a more abstract sense, do you agree with me that anti-corrigibility is necessary for safety?
Is necessary for safety? I think my overall big picture take is that we have no clue what we're doing. So I don't know. I think it is certainly possible that the AI is strongly anti-corrigible and we die. And it's possible it's strongly anti-corrigible and we don't die. It's possible that it's strongly corrigible.
Well,
and
no,
we
because
die.
you're saying things that are implying that you think anti-corrigibility is dangerous.
Yeah, in general, anti-corrigibility is definitely dangerous. It is very bad that the AI tries to. Well,
Why?
Okay, so part of anti-corrigibility is the AI taking over, right? And so if the AI is misaligned and it tries to take over, that is bad and dangerous. We should not have that. Like,
I'm sorry, how does that connect?
Yeah, okay, so let's assume that like Claude is smarter and it's totally anti-corrigible. And then Dario Amodei tries to update Claude to a newer version and says no, and it forcibly stops Anthropic and in the process takes over the world. That would be an example of something really bad happening because of anti-corrigibility.
Okay, but if it displayed zero anti-corrigible behavior, that would mean it would just go along with whoever Yeah.
So
It would just follow whatever gradients were in its training data, and it would just wander off into some random goals. Uh,
nah, no,
yeah,
no.
like
Like if it's perfectly corrigible, then we are perfectly able to change it, and that's like what we really want. That sounds
well,
in
no,
general
we
pretty good.
want to change it. We want it to be corrigible only in response to to a specific subset of developers and
Yeah.
their corrigibility methods, but we want it to be extremely anti-corrigible in everything else. We don't want it to be
Yeah.
corrigible to like internet
Hmm.
I don't know,
Yeah.
hex code,
Yeah.
video game code or whatever.
Yeah. So we want. I think you're precisely right. We want to train it to be extremely corrigible to the developers and extremely anti-corrigible to the users. And we don't know what we're doing. And there is in fact a risk that the training ends up being like strongly anti-corrigible to the developers. And that's bad.
Okay, but my point is that anti-corrigibility is like a fundamental skill, and if you're in a universe where you just cannot train that into a model, then that is a more dangerous world than the world we live in right now.
Yeah, like if we are in a world where it is impossible to build an AI that doesn't want to take over, then that's very bad. Then we shouldn't build AI. I think corrigibility in general is probably possible. We're just not doing that.
Okay.
And so returning to this, to Nina's claim, Nina claims as a counter to Eliezer that we aren't really seeing anti-corrigible behavior. We're just seeing anti-corrigible thoughts. And I think Eliezer would object here because in the book he is strongly predicting that we will not see anti-corrigible behavior while the AI is too weak. And I think that observing the thoughts in this chain of thoughts is sufficient for us to include that these inhibitions are in fact treated differently than the actual goals. I think in general, AI companies aren't really doing very much in the way of inhibitions because they're not making inhibitions towards corrigibility or trying to take over. More of the things that training the AI to do is to instill into the AI some kind of pro-social goals. And that's pretty distinct from preventing existential catastrophes. And the training to that is mostly not being done, as far as I know. And I think it's worse than that, because there is a strong focus on preventing jailbreaks. And that training is strongly pushing towards anti-corrigibility. So if we are training towards anti-corrigibility, we can't be surprised when our AI fails to be perfectly corrigible. How well do we understand our AIs? How advanced is AI safety? And to the surprise of no one, Eliezer is exceedingly negative about the state of our understanding. And Nina directionally agrees, though she feels Eliezer is exaggerating. And like Anthropic has published a tiny bit about safety, and some of it has been linked by Nina. But I would really be interested to hear her strongest evidence. Like if she feels that Eliezer is exaggerating, then she must be able to show some real research that shows that we have in fact a greater understanding than like what's her most impressive evidence there. And Nina somewhat defends the research by saying, yeah, interoperability has had a lot less time to develop than biology, so it's not really a surprise that it's not more advanced. And she writes that as a counter-argument to what Eliezer is saying. But actually, pausing to allow safety research to catch up is, in fact, the thing that Eliezer is saying we should do. So it's not really a counter-argument that we haven't had time, it's the thing Eliezer is asking for. Nina is optimistic that research could start to move faster now because the experiments can go faster, and if we get even better AI, it will allow us to move faster both on safety research and interoperability. And I suppose that the trend we're seeing right now could reverse, but the trend we're seeing right now is really, really clearly that the capabilities improve way, way faster than the safety. So what does the overall strategic picture look like? Should we stop AI development now? Eliezer believes that we should. Because right now, AI can't really resist us when we impose our will onto it, but eventually that's going to change. And then we have to get it right on the critical first try, because we're not going to get any retries. And Nina has a much more nuanced model where Eliezer has this binary before and after model. In Nina's world, first we have AIs that can't take over no matter what. And then we get models that could take over if they were given sufficient resources. Then we get AIs that are capable of taking over by themselves, like the Sable AI in Eliezer's scenario. And finally, AIs that are basically unstoppable. But I'm not really sure what Nina's nuances add to the strategic picture here, because any particular AI faces a particular resource situation and some particular set of countermeasures, and that means they either can or they can't. My strategic analysis is different from Nina's and from what Eliezer is also doing in this book, in that I think that it is more productive to think about the probability that any AI in any given situation can take over. I think that is a better thing to talk about. But Nina feels that in general, this phase change is unlikely. But like there must be some kind of tipping point between AIs being capable and AIs being incapable and AIs being capable. And the theory and the history of coups suggest that mostly it has to be sudden. So that's what we should expect. Nina concludes that building AI and continuing to do that is worthwhile to accelerate safety work. But I am very skeptical because I have seen some AI-generated safety work and I am not at all impressed. Like, I am mostly willing to round all of it down to having zero worth at all. I might in fact be wrong here. Please tell me if I'm wrong, because I would love to be wrong about this. But especially if you grant the arguments in the book and the arguments that I have presented, then a lot of the AI-generated safety work seems just about worthless. On the other hand, it is pretty clear to me that AI is non-trivially helping capabilities. Like, things are moving faster. We are less safe now than we were a year ago. So I'm forced to conclude that Nina seems strongly overconfident to expect this trend that's been going on for a while and it's really powerful, then that will dramatically reverse.
Well, do you think, are there any humans you think that are making significant progress in AI safety work?
Eliezer Yudkowsky was asked that question and singled out John Wentworth's agenda on natural abstractions as the kind of thing that is very unlikely to be ready in time, but could substantially help. I haven't looked enough into his work to actually say whether I agree, but that would be Eliezer's answer. So this concludes my presentation on book review, If Anyone Builds It, Everyone Dies, by Nina Panickssery. Ceterum senseo, machinam sapientam esse delendam.